All right, for tonight's homework, I would like you to first explain to me what your partner did wrong on the quiz best you can. So if you're a person who did poorly on the quiz, tell me what you did. If you were an advisor, try to tell me on paper or show me on paper what they did. But again, the first part of your homework, explain to me what your partner did wrong on that quiz we took yesterday, or explain what you helped them with. That's the first part of the homework. Do that on paper. Explain to me what they did wrong on that quiz. The second part of your homework is copying down these two problems and the words I'm saying to show that you listen from beginning to end. So hopefully you have graph paper. These problems are dealing with proving if the lengths of a triangle make up a right triangle by proving they work in the Pythagorean theorem. We're using the distance formula. For this problem right here, I need to find the three lengths, plug them into the Pythagorean theorem. If they work, it proves this triangle without a doubt is a right triangle. To find two of these lengths, I could see all I'm doing is counting straight boxes. Straight 5 for AB, 4 for AC. But when I go to count boxes for CB or BC, I can't just count boxes. I need to use this distance formula. And the distance formula just has you take the two x coordinates from these 2 points, find the difference of them, take the two y coordinate numbers from those points, find the difference, subtract them, square them, and then square root them all. So point B, first word is blue. Point B is 7, 1. Point C is 2, 5. Those are my x and y numbers from the points B, C, 7, 1, 2, 5. I'm going to find the difference of these two x numbers, 7 and 2, and then find the difference of these two y numbers, 5 and 1. Since I'm squaring these, it does not matter the order you put these in. I could go 7 minus 2 or 2 minus 7, does not matter. I'm just going 2 minus 7 because I like to go left to right. 2 minus 7 squared plus the difference of the two y coordinate numbers, 5 minus 1 squared. That gives me the square root of -5 squared plus 4 squared, which gives me the square root of 25 plus 16, which gives me the square root of 41. I'm going to leave this as a radical. I'm not going to find this as a decimal. I need you to see that root 41 is the biggest number out of all three of those. If I was to use a calculator and square root 41, it would give me 6.4. So clearly this is the longest length, 6.4. So when I plug them in, second word is whale. When I plug these in, I plug in the two smaller values, 5 and 4 here. But this bigger one, root 41, which is really 6.4 in disguise, I put that in the hypotenuse spot. And then if I do the math and it works, it proves those lengths without a doubt. Make the Pythagorean theorem works, which proves this is a right triangle, guaranteed. This is my proof. Each length works in the Pythagorean theorem, plugging in the right spot. Third word is green. All right, last problem, reviewing more linear kind of math, knowing that this red line is y equals over 3 up to 2/3 x plus 3. That is my equation of this red line, 2/3 x plus 3. I want an equation and graph of a line perpendicular. So if I take that 2, 3 and flip it to 3, 2, and then opposite it becomes 3 over 2, but -3, 2. So I could choose anywhere along this y-intercept to start. I'm going to choose at the same y-intercept just because it gives you that nice neat look. I could have started anywhere I wanted as long as I follow that right 2 down 3, right 2 down 3 rate of change or slope, because that is perpendicular to a slope of 2/3, and you can see clearly a 90-degree angle right there. One line perpendicular to the other, 90 degrees. All right, last word is pillow. Good luck.